Hello everyone, welcome to my lecture. Here, let's have an introduction to analytic functions. Analytic functions from complex analysis. Yes, here you can see the definition of analytic function. A complex valued function. This is the I think this is the most basic topic from the complex analysis. Yes, so a complex valued function f of z is said to be analytic at the point z equal to z naught if f dash of z equal to, that is, limit delta z tends to 0, f of z plus delta z minus f of z by delta z exists and is unique at z naught. Okay, so when can we say that in a function f of z, it's a complex valued function, when can we say that it is analytic? We can say that it is analytic at a point, at any point, at a point z equal to z naught if this limit exists and is unique at that point z naught. And this limit is nothing but f dash z. That is the derivative of that function, that complex valued function at that point z naught. If this derivative exists or if this limit exists, both are same only, we can say that the function is analytic at that point z naught. Okay. Yes. The next one is Cauchy-Riemann equation. Okay, you can see Cauchy-Riemann equation. With the help of Cauchy-Riemann equations, we can check whether a function is analytic or not. Okay, so Cauchy-Riemann equation helps us to check whether a function is analytic or not. If a function satisfies Cauchy-Riemann equation, we can say that that function is analytic. You can see here, suppose you have z equal to x plus iy, a complex number, and suppose f of z equal to u of xy plus I v of xy. That f of z is a complex valued function. So we can split it like this. It has a real term and a complex term, complex part. So that's why this u of xy, that is the real part, and the v of xy is the complex part. And for our z, x is the real part and this iy is the complex part. Then these are the Cauchy-Riemann equations. If this equation is satisfying in our function, in our f of z, we can say that that function is analytic. So the first Cauchy-Riemann equation, dou u by dou x will be equal to dou v by dou y. Also, the second one, dou u by dou y equal to minus dou v by dou x. These are known as Cauchy-Riemann equation. If a function satisfies this equation, we can say that that function is analytic. Let's see one example here. Let's see how can we check whether a function is analytic or not using Cauchy-Riemann equation. See here, we have the function f of z equal to z square, where z is what? X plus iy. Z equal to x plus iy. F of z is defined as z square. Let's see whether this function is analytic or not. Yes. So f of z equal to z square means we can write that is x plus iy the whole square. Z square means x plus iy the whole square, right? Because z equal to what? X plus iy. Now expand this using a plus b the whole square. A plus b the whole square, a square plus b square plus 2ab. So a is x here and b is iy. So first a square becomes x square, b square becomes square of this iy, square of this iy, that is I square y square, plus 2ab means 2x iy. 2ab means 2x iy. That means x square and this I square, we know that it is minus 1. Okay, I square is minus 1. So I square y square means minus 1 into y square, that is nothing but minus y square, plus I into 2xy. I into 2xy. Now we got u of xy and v of xy power f of z. Okay, so this is the standard form of our f of z, right? F of z equal to u of xy plus I v of xy. Now we have approached that form. We have reached that form. This x square minus y square will be our u of xy, and with this I, the coefficient of this I, 2xy, that is our v of xy. So that's what you can see here. U of xy equal to x square minus y square, and v of xy equal to 2xy. Now we can check whether this function, this u and v are satisfying Cauchy-Riemann equation or not. Okay, so Cauchy-Riemann equation you can see here, dou u by dou x equal to dou v by dou y, and dou u by dou y will be equal to dou v by dou x. If this is happening, we can say that it satisfies Cauchy-Riemann equation. That means it is analytic. So for that, we have to find the values. We have to find the expression for all the four. Find dou u by dou x, dou v by dou y, dou u by dou y, and dou v by dou x. Find all of them. U and v are available here. So we can see first, this is E, this is U, U of xy equal to x square minus y square, and this is V, V of xy equal to 2xy. Now find dou u by dou x. Now, we know that it's a partial derivative. So partial derivative means we can find partial derivative of two variable function by taking one variable as constant. For example, if we are finding dou u by dou x, we are differentiating with respect to x. So we will take y as a constant. That is the meaning of partial derivative. Okay, y is actually a variable, but while taking partial derivative with respect to x, we will treat this y as a constant. Only we will consider this x as a variable. Similarly, if you are finding the partial derivative of a two variable function with respect to y, then we will treat x as a constant and we will differentiate with respect to that y. Everything else is same as our usual derivative. So see here, what is dou u by dou x? So this is u. Dou u by dou x means we are differentiating this with respect to x. We know that the derivative of x square is 2x. That 2x is what you can see here. And y we are treating as constant because we are differentiating with respect to x. So this is a constant means the derivative of constant is 0. So the derivative of y square becomes 0. It vanished here. So this is only 2x. Similarly, we can find dou v by dou y. Dou v by dou y means v is available here, and dou v by dou y means we are differentiating this v with respect to y. In that case, we will treat x as a constant. So see here, v is 2xy. Let's differentiate this with respect to y. We will treat x as a constant. 2 is already a constant, so 2x is a constant. Okay, so a constant into y. What is its derivative? That constant only. That's what you can see, that 2x only will be here. Okay, so dou u by dou x is 2x and dou v by dou y is also 2x. That means dou u by dou x and dou v by dou y are equal. That means the first Cauchy-Riemann equation. The first Cauchy-Riemann equation satisfies here. Dou u by dou x equal to dou v by dou y. Okay, so first Cauchy-Riemann equation. Okay, now to conclude that this is analytic, we need that second Cauchy-Riemann equation also. Okay, that means dou u by dou y should be equal to minus dou v by dou x. Let's see here, v and u are available here. So first find this dou u by dou y. So what is dou u by dou y? This is u. Dou u by dou y means differentiating this u with respect to y. So we will treat x as a constant there. So derivative of this x square becomes 0 and derivative of minus y square is minus 2y. So dou u by dou y is minus 2y. That's what you can see here. Dou u by dou y equal to minus 2y. Next we need what? Next we need minus dou v by dou x, or dou v by dou x we need. Here v is available. Let's find dou v by dou x. We are differentiating with respect to x. So we can treat that y as a constant. So this becomes 2y into x. 2y is a constant. So its derivative will be only 2y. Okay. So that's what you can see here. Dou v by dou x equal to 2y. So dou u by dou y is minus 2y and dou v by dou x is 2y. Okay. One is the negative of the other. Okay. 2y is the negative of minus 2y, or minus 2y is the negative of 2y. That means dou u by dou y is the negative of dou v by dou x. Okay. So dou u by dou y equal to negative minus dou v by dou x. This is nothing but the second Cauchy-Riemann equation. Okay. Dou u by dou y equal to minus dou v by dou x. That means we can say that The two Cauchy-Riemann equations satisfies here. That means this function is analytic. I hope it's clear. Thanks for watching. We'll meet in the next video. Bye.